All right, we'll get started right now. Good morning, everyone. I just want to welcome everyone for joining us. Thank you for joining us today. My name is Mark Zaborny, and I'm the marketing manager here at DME. Today, we're going to be deep diving into controlling the action, mastering plate motion with DME EZ-Latch and reverse EZ-Latch locks. This is going to be a comprehensive, hands-on session designed to help you unlock the full potential of your mold plate sequencing and control. I'm thrilled to introduce our featured presenter, Jeremy Sutch. Jeremy is our Director of Engineering here at DME. Before we begin, I want to cover a couple of housekeeping items. If you have any questions or comments during this webinar, please feel free to enter them into the chat, and we'll address everything at the end of there. We'll go through all your questions and answer them there. Also, we will be recording this, and we will be sending out this a copy of this webinar over to everyone as well in the email later on this week. Also included in that email will be additional resources that we'll be sharing along the way. Also, don't forget to mark your calendars for next month on July 29th. We'll be having another webinar for with Fresh Starts. So if that interests you, please sign up. You can go to dme.net/webinar to get a registration, and we'll also be sharing that like we normally do throughout the month on there. Again, if you have any questions, comments, put them towards the end. I'll be sharing a few links. And now we have that already, I'll give the floor over to Jeremy. Jeremy?
All right, thank you, Mark. And thank everyone for attending our webinar here today. And we thank many of you that have come to the entire series of webinars that we've had in this year. And as Mark stated, we have, I think, 5 more to go. So we hope to see you there. Today, we're going to be talking about mold components. We're going to be talking about DME's EZL and R-EZL mechanical latch lock products. As Mark said, I am Jeremy Sutch, Director of DME Engineering, and joined with my colleague Anakalam Ramakanth, DME Engineering. He'll be with us until the end of the presentation to help me with some questions and answers. So please jot down your questions, and we look forward to fielding all of those. The DME EZ-Latch products are a perfect solution for mold-based plate control. DME stocks a wide variety of standard configurations that satisfies most applications. Special configurations are available upon request. These latch locks feature a positive mechanical locking system that eliminates the need for springs, shoulder bolts, friction components, or hydraulic cylinders. The EZ-Latch products are rather simple devices that can be configured for a variety of applications, but we do understand that the product's versatility, depending on how it's installed, can be difficult to understand and therefore difficult for the mold designer to choose component part numbers. Our presentation today will discuss the product's applications, but more importantly, introduce the market, our customers, to our new R-EZL Cadence part solution configurators, which significantly simplifies the specification of the latch lock components. Most of our U.S. Customers probably recognize part solutions as part solutions. Our European friends are more common with the Cadence, and most likely I will be using the term Cadence throughout the majority of this presentation. So we move into our presentation here. Both the EZL, which is primarily for 3-plate control, and the R-EZL products, which are also multi-plate control, but kind of operate in reverse nature. The construction of each and the 3 primary components are the same. We have the latch body, we have the retainer, and the latch bar assembly. The one key feature that's different between the EZL and R-EZL is that the EZL product uses an internal cam, which we're going to see in a moment how that works, to hold the internal components into position at complete mold open so they can be reassembled as the mold closes. The R-EZL latch products do not use a cam, but simply rely only on the latch bar and the retainer and the body. There are different options available with the R-EZL products, including extended latch bars. Again, these are just options, and the configurator will help with that if necessary. And we're going to take a real quick moment to jump into a video just to show how the EZ-Latch products operate.
Introducing the EZ-Latch lock. Simple and effective for 3-plate control. Let's explore the EZ-Latch lock, focusing on its main components: the latch bar, the fixed latch body, and the retainer. Here, observe how the latch body remains fixed, while both the latch bar and retainer move. Now, let's examine the latch lock in detail. Notice how the retainer's position dictates the first stroke, S1. During the initial stroke S1, the retainer and latch bar move together. After S1, the retainer releases the latch bar to complete the final stroke, while the retainer stays stationary. Notice how the cam holds the segments in place within the retainer when the latch bar is fully disengaged.
So we'll come back to the operation of the mechanism here in a moment. The first product that we're going to focus on is actually the EZ-Latch products, which are designed specifically for 3-plate control. We talked a few moments ago about the 3 primary components: the latch body, the bar, and the retainer. And on this slide, you can see the configuration of the EZ-L, where the body is mounted on the top clamp plate, the retainer is mounted on the A plate, and the latch bar is mounted on the B plate. So I chose a video of the EZ-L product to demonstrate or to show the actual cam action that holds the components, the internal latches in place when the mold is completely open. Again, the R-EZ-L products do not use that cam. In specifying a particular product for a mold application, it's really 3 easy steps, but they can sometimes get a little confusing. Step 1 is to determine what the stroke is, or what the distance is required between the plates when opened. Once that is achieved, we come back and we have to determine what length of body is going to be necessary to keep the components in place through the process. And then the third step is to select the bar length best suited for the mounting on the B plate. So our first configurator is only for the EZ-L products, and I'm going to be bouncing back and forth between the presentation and the website, so bear with me through that, what can be rather clumsy process. But the one thing that I think is very, very key, if you haven't already picked it up, which most of you have, is the real importance of the design and component selection and how these are mounted is the stroke adjustment. And I'm probably going to repeat this multiple times through this presentation. The stroke adjustment is set by the mold designer, and it of course is determined by the physical mounting position or relationship between the body, the retainer, and the bar itself. And this is where the configurator is such a good aid for the mold designer, because again, calculating those things, although not difficult, is rather cumbersome. And the configurators that we have built now make this process pretty much automatic for the mold designer. So I'm going to jump over to one of our Cadena sites. So as of right now, via Part Solution DME, posted this morning, we only have the EZ-Latch. We were debugging the R-EZ-Latch configurators late last week. We found a couple bugs, so we're working through those, and we do expect to have the 3 R-EZ-Latch configurators over on our standard Kadena site by the end of today. But just looking at our configurator here, I'm going to just jump back one screen here. We're going to go ahead and use the 55 series for our example this morning. As you can see, there are 3 different sizes in the EZ-L product. There's a 45, 55, and a 75. So we're going to start there. This is based on loading and things of that nature, which we can discuss as we get into the question and answer period. But we're going to use the 55 series for our application today. So basically, in looking, if I was mold designer looking at my plate stack up and so forth, I pretty quickly determined that I'm going to use a 120 millimeter length body, and I'm going to use an 80 millimeter long latch bar, and I'm going to want a stroke of 20 millimeters. So I'm going to change those variables there. And then as the CAD is updated, and this is what I was trying to explain a little while ago, the CAD that is generated now has properly positioned in relation to one another the latch bar, the retainer, and the body. So basically the stroke that the designer was looking for has now been set in your CAD model, which you can then of course download, put right into your mold design, and move on from there. These slides here basically just show the action of the EZ-L product. You can see it mold closed. Of course, everything's stacked up and all the components are in position. Per the video that we just watched, at stage 1, as the mold begins to open, then the retainer and, well, the latch bar is going to move until it comes up to the retainer position, and that's when it's going to, the latch bar itself is going to move the little retention tabs out of location, release the latch bar, which is then going to stop the movement of the intermediate plate, and then the mold will continue to open, taking the latch bar with it. And then of course, as noted, the cam action within the EZ-L product holds those retention tabs in place. So when the mold comes and closes, everything's in alignment, ready to be captured by the latch bar as the mold closes. Now moving on to our reverse or R-EZ-L latch products. Here again, multiple plate control, but these can be, configured and oriented on the mold in different ways for different applications. As noted, the EZ-L product uses the internal cam. The R-EZ-L products do not use the internal cam. Essentially, all of the action is obtained via the latch bar and the retainer. So we've already talked about our Kadena site. We're going to bounce back over there in a moment. But in this presentation for the R-EZ-L products, we're going to be looking at 3 specific applications, possibly 2 more if time allows. 2-stage ejection bottom last plate, 2-stage ejection top last plate, and then bottom last stripper plate and ejector pin ejection. So in the 2-stage bottom last setup, you can see here that we've got the body is mounted on the ejector plate. The top ejector plate is where we're mounting the retainer, and the support plate is mounting the latch bar. Again, we want to focus this presentation primarily on the new configurators to aid the mold designers. I do believe that we're going to make this particular presentation available in PDF after the presentation if you want to grab that. But I'm going to go ahead and, like I did on the EZ-L products, I'm going to bounce over into Cadence and pull up this configurator and just demonstrate how easy it is to use. So we're going to do the bottom last. So we're going to choose, here's our 3 applications here. Again, this will be pulled over into the general DME CAD site by the end of today. So we're going to come over into our bottom last and we're going to start looking at our variables. For this particular demonstration, we're going to use the standard body length and the standard bar length. Those bar lengths and body lengths are established and can be modified here. These are standard products that we're talking about in using the configurator. And you can see that once those are selected, right here, the configurator is actually generating the DME part number that you'll be then able to use on your bill of materials, and then, of course, eventually down the road to purchase via DME e-store, customer service, or whatever you choose. Now, very similar, or really the same as the EZ-L products, but again, the R-EZ-L gets a little bit more complicated because you're talking about multiple strokes essentially. So for this application, I'm going to go ahead and choose the bottom last stroke of 30 millimeters. And I'm going to choose the max second stroke as 0. And I'm going to do so in a mold close. Whoops, I'm sorry. We'll do it in a mold open position. Again, I'm going to update the CAD just like in the EZ-L products. And again, most important through this configurator, the relationship now between the body, the retainer, and the latch bar is set for the mold designer in this condition. So that takes away the mold designer trying to determine, again, exactly where he's going to mount these components on the plates. We have another 3 view here that demonstrates what's happening as the mold opens and the latch bar is doing its job. Here in this first position, you can see that the latch bar is still engaged in the body. The retainer is basically at the release position here. Mold continues to open, plates move, and the body is moving this time. All right, so the body is moving around the retainer. We get to the next stage. It releases a point in the body that the retention tabs are released. And then we go to the next stage here of ejection. I should also note we have very good videos of all 3 of these applications posted on the DME YouTube channel. So sometimes it's really hard to see the action in only a 2D presentation like this. So we would encourage you to take a look at the YouTube channel and you'll be able to see all of these options in action. Next up is, again, 2-stage ejection, top last plate control. A slightly different configuration here. We still have the body is mounted on the clamp plate. The retainer is mounted on the ejector plate. And the latch bar is mounted on the top ejector plate. So again, just to not be too repetitive, but try to demonstrate how easy it is to use the configurator via Cadence. I'm going to jump back over to our top last configurator. It's going to bring me in here. Similar to the last one, I'm going to leave the standard body length of 120 millimeters, standard length bar, 60 millimeters. And I'm going to leave the standard extension. And again, just like before, you can see that the DME part number for that assembly has been generated here. I'm going to move in, I'm going to input again my 30 millimeters for the top last stroke. I'm going to leave the second stroke at 0. Mold closed position. Generate new CAD. You can see how that has changed the relationship again between the latch bar, the retainer, just immediately within the CAD for the same purpose to set those variables so the mold designer doesn't have to try to figure them out on his own. Sorry, I got a little lost there in my presentation. The last common application that we want to talk about is bottom last stripper plate and ejector pin ejection. So here you can see we've got longer bodies and so forth. The configurator is going to be a little bit different because of the bar extension. Similarly, we see the bodies mounted on the ejector plate. This one, the latch bar is mounted on the support plate, and the retainer this time is mounted on the stripper plate. Here again, we're determining everything by the strokes. And then the other configurator that unfortunately we're not quite fully debugged yet on that one. So I'm not going to be able to walk through a demonstration of the configurator, but I think, you know, it operates in the exact same way as the other two, relatively easy. But same thing, you're going to set the body length, bar length. It's going to generate a part number for you. And then you're going to adjust your stroke in the condition in which you want to receive the CAD. Download the CAD and you'll be good to go. And here we're seeing the action when set up with the stripper plate. The retainer is captured by the body, and both the retainer and the body move together during the first stroke. At ejection stage, stripper plate and ejector plate move together for the designated stroke 1, allowing the collapsible core, in this case, to collapse and clear the undercuts. When the first stage of travel is complete, the retainer releases the body via the floating retention tabs. And then as we move into stage 2, the ejector plate continues alone to complete the part ejection using the ejector pins. In the final stage, the retention tabs lock into the bar grooves, releasing the body to move freely. Limit bolts, which we're not going to get into that detail, but it is specified in the product installation information. Limit bolts are what's preventing the stripper plate from over travel in this application. So those really conclude the 3 standard R-EZL configurations, as well as the EZL application. I do see we've got a few minutes here, and a couple of more applications. These we don't really have configurators for, but DME Mechanical Engineering is always readily available to help the mold designer. But we could use R-EZL for a common, kind of similar to what we were looking at a minute ago, but slightly different, collapsible core application. Again, no configurator for these applications, but DME, actually, I apologize. These configurators are not up yet, they're forthcoming. So I misspoke there. And this is how they operate. And again, this presentation will be made available to you. And specifically to the DME S-Core collapsible core, we have special mold-based designs to use for those. And we're still using the R-EZL products for our plate control. Again, this is actually an engineered solution that DME Mechanical Engineering will work with you on. Again, configurator forthcoming. And operation. So that does conclude the formal presentation. Mark, were we going to do Q&A at 30 past? Where are we at?
Yeah, so we do have some questions in. They're coming in right now. Also, everyone on the call, if you do have questions, please put them in the chat. We'll get back to you on here, and we'll answer them on the call. First question we have is, what's the difference between the EZ-Latch and reverse EZ-Latch lock? And when do you use them?
Well, so the EZL was really the first product in the family, and it was designed specifically for plate control, 3-plate control. I apologize. The key difference between the two assemblies, the EZL and the R-EZL, is really the cam mechanism that we looked at in that little video. I don't really have a real good picture of it here. The cam actually sits under the latch bar in the retainer right here. And so as the EZL is moving, when it gets to the end of that stroke, it is going to release the latch bar to continue on, but the cam rotates when the latch bar rolls out, which pushes the retention tabs in place in the body and holds them there, so that retainer is there for recovery when the mold begins to close. The R-EZL products do not use the cam mechanism. It's only detents in the bar itself and within the body.
Okay, great. And then how do you select the correct latch lock size for your mold?
Well, here again, this is really why we created the configurators. When it comes to the EZL product, it's relatively straightforward, right? I mean, the mold designer is going to know what he's going to have for stack up with regard to what he needs for a body length. The stroke is going to help determine the bar length. But again, you could jump back over into Cadenas. Just with those generalities, you can plug those in and actually dial in exactly what you want for stroke. Again, everything presented here are standard off-the-shelf components for DME. So, right, standard body lengths, standard geometry within those body lengths, standard latch bar lengths, and of course the retainer is the same for all of the products. So again, generally just physically mounting, the mold designer is going to get there pretty quickly on his own. But again, bearing in mind the actual stroke, right, the timing of the plates and the distance that they're opening is being established by the physical relationship between the three components. And that's what makes even the EZL configurator, which is really almost more of a part selector, it even helps with a more simple product. Once you put the stroke in with your standard components, it's going to set that CAD and be easy to import into the mold design.
Okay, awesome. Another question we got in right now is, what are the base steel materials of the working components? Are they hardened tool steels, coated soft steels? What are they?
Rami, you know all those specs by heart. Can you join me and answer that question, please?
And let me unmute you, Rama. There you go.
Yes, Jeremy. Yeah. So actually, body is made of pre-hardened 5140 steel, and the latch bar, adapter, and retainer, they are actually made of H13 tool steel. So, and all the parts are nitrided and also hardened. So I think that is excellent for wear resistance and long life for the latch locks. So yeah, that's the materials.
Okay. And what is the tolerance of the stroke?
It's a tenth of a millimeter. Yeah. Go ahead, Rama.
Yeah, actually, a stroke usually it's better to add 0.5 millimeters additional, because if you are using any stripper board. I'm just to make sure the latch bar, actually the retainers release the latch bar. So yeah, it's 0.5 millimeters.
Okay. And then just a reminder to everyone, I included in the chat links to where you can find it on the eStore, some brochures, the videos that Jeremy was talking about. And also, if you have additional questions after the webinar, you can obviously talk to Mech Engineering. We could talk to your sales reps. We are available for you. Another question we got in right now is special machining required to install these locks?
Nothing out of the ordinary. No special machining, just some pocket work. Nothing at all out of, nothing other than what a mold designer would expect to be included. So no, nothing special with these. And again, maintenance free. There are some longer term maintenance issues, but these are designed to be, again, off the shelf, readily available. Again, with the addition of the new configurators, an aid in selection for the mold designer, put them on and not worry about them, right? As Rama was explaining with the materials and the coatings that we're using, these should be, in service for hundreds of thousands of cycles before anything needs to be dealt with.
Okay. Well, with that being said, the regular recommended maintenance schedule, you said 100,000, 200,000 cycles?
Yeah, I was being general. Rama, can you help me with the actual specifications?
Yes, around 200,000 cycles or monthly. You just have to check basic things that anything is wearing out, or just check the fasteners whether they have loosened. So such checks after every 200,000 cycles, and every 6 months it's better to inspect the whole latch lock. If it is worn out, maybe you should think of changing any spare parts. So yeah, and all the spare parts are actually readily available. They're all off the shelf. So
very cool.
So,
and then so we pretty much get a pretty long life out of the latches on there. Okay, another question came in. So just for clarification, no modifications to the latch locks are required. Only plate machining for mounting?
That would be correct certainly when using all the standard products, right? The latch lock's going to come out of the box. It's going to bolt to the mold plates right where the mold designer says to bolt them, and it's done. Again, we do offer special configurations, in which case you'll actually be working directly with one of our engineers at DME Mechanical Engineering, and we'll get special part numbers and quotes and so forth for any special components. But no, under normal circumstances, no modifications whatsoever.
Okay. And then what are the competitive solutions and what are the advantages and disadvantages of these?
Well, I'm going to say generally, I mean, there are similar products on the market. I think number one, with the materials that we're using and the coatings, again, there's nothing super sophisticated there, but we're certainly, we develop and delivering a product that is intended for very long life, so customers get their money's worth. I would say the versatility, especially of the REZL products, and now with the benefit of a configurator, it is rather, the R-EZL are rather unique, and I haven't seen a lot of direct competition with the product. And again, now that the configurator is available, or will be by the end of the day, apologies that we're still in beta. I really think if you take a look at the product, again, the diversity of the applications, cost and availability, I think it stands alone in the marketplace.
Agree. Yeah. The plug and play, how easy it is, eliminates needs for springs, hydraulic cylinders. It's a good thing. In the 3-plate configuration, it looks like the system pulls the gate drops and pulls open the pullers. How does the A plate open from the parting line? And do you need a shoulder bolt? Do you need shoulder bolts across the parting line?
No shoulder bolts. Rama, do you want to walk through that? I'm not sure if I can give you control of my screen. Can you just talk over the slide, Rama?
Yeah. Yes. Actually, we just need a shoulder bolt to pull this plate, which is pulling the runner. And usually in our standard designs, we also have shoulder bolts linking the linking to the top clamp plate. So that shoulder bolt is not required because that function is taken care of by the body of the latch lock. So yeah, we eliminate one set of shoulder bolts if we use EZ-Latches.
Okay. And then what is the additional cost to going with the custom configuration?
Well, everything is going to have to be quoted. I mean, obviously, if we get into, custom bodies, they're going to be a little bit more expensive to manufacture as one-offs. The mount of the latch bar itself is common across the product line. So if we need a special length bar or a bar extension, that's really not that costly. So, again, it all depends on which component has to be special manufactured. Like anything else, it's going to be quantity driven, which is going to be low. So again, special applications will be looked at, by our engineering staff, and then we'll run that through the manufacturing models to establish a cost and get a quote out.
Okay, perfect. And did you just have a question come in? I saw something on the screen there.
Apologies, I don't know if that was for the webinar or if that was related to other business.
Awesome. Okay. While we're waiting, I answered most of the questions that came in here. If anybody has any last minute questions, any things like that, we are available. Again, I put in the chat the links, and we will be sending out a copy of this webinar, the videos, along with as soon as the configurators are up and running, when they're perfectly working, we'll send that to you, and that should be probably by the end of this week. Once we get the videos updated, along with all the literature we have as well. So unless there aren't any other questions.
Mark, I actually did receive one in via personal teams here from a colleague in Europe. The question is, what is the market acceptance of EZL and R-EZL products? And how is our volume on them? I would say certainly, I'm much closer to the U.S. market, the U.S. team than the European team. But we've got a lot of activity on the EZ-Latch products. Also, though, a lot of guiding for the mold designers, which is really why we wanted to kind of introduce and make sure that the market's aware of the new configurators, especially for our EZL products. Our engineering staff, it was common daily, multiple times a day, that we were helping customers specify product, and not only to alleviate some of that burden from our team, but also to put a tool in the hands of the mold designer so they can spec what they want and get on their way. And I think as again the configurators are brand new, we have not even yet had training with our commercial teams globally. So I think as we now roll this out, we get it into the hands of our sales leaders into the market, I think we're going to see a lot more activity again, because it's going to be much easier to select the product.
Good deal.
Any other questions, Mark?
I think those are the rest of the questions we have right there. So I think with that, I guess I just want to thank everyone for attending today. Again, we will send out all the information over to you. I want to thank Jeremy and Akala for helping us. And once again, if you will have any additional questions, contact your DME rep. We're available also through the e-store, through chat there, and we'll be happy to help you out.
Mark, I think we'll send Yep, Mark, I think we'll send a blast out via LinkedIn or even the email list that we have here from attendees. As soon as we get the beta site fully integrated with the standard DME site, we'll send out a notice just to let everybody know everything's up and running correctly.
Perfect. Awesome.
Thank you, everyone. We appreciate your time this morning.